Today our goal is to find complex number solutions of quadratic equations, and we're also going to be learning about the properties and be able to identify complex numbers. Complex numbers, we use an imaginary unit I. I squared is -1, and I equals the radical -1. Most of today I want you guys to be looking at and trying to find radical -1s in here, and that'll help us find the imaginary unit I. So last week we talked about the quadratic formula. With the quadratic formula, remember, if we got a negative under the radical, we said there were no real solutions. That's because there were complex number solutions or imaginary solutions. A complex number is written in the form of a plus bi. If it's just a pure real number, which we typically work with, we just have a single number, no I added in. If it's a pure imaginary number, we have only imaginary numbers, and we'll see a lot of those later on. Some properties of complex numbers include I to the 0 power is just the number 1. I to the first power is just I to the second power is a -1. I to the third power is a -I. I to the fourth power is the number 1. I to the fifth power is the letter I. I to the sixth power is a -1. I to the seventh power is a -I. I to the eighth power is the number 1. The pattern is that every 4 numbers for the exponent, the cycle repeats. The reason why this works is that the radical -1 to the 0 power is just going to be 1. That is true for any number. If you are taking a radical -1 to the first power, it's just going to be itself, which is the letter I. If you are taking the radical -1 to the second power, you are going to treat it like you had a radical -1 times a radical -1, which would simply take out a date of -1. And the last one, I to the third power, or the radical -1 to the third, is like you had 3 of the radical -1s. You can take 2 of them out to create a negative, and then you would have the radical -1 still left. So that gives you a negative I. When you simplify something with a negative under the radical, we're going to rewrite it using the imaginary unit I. And now I'm going to use a lot of factor trees for this one so you can see how it breaks down. So with this one, I can break it into a -1 and the number 18. The number 18 breaks down into 9 and 2, and 9 breaks down into 3 and 3. Remember, when you are making these factor trees to simplify radicals, you're going to take out a date if you can. Now, whenever you see this -1 underneath the radical, that's going to become the letter I. So I could rewrite this as I times 3 radical 2. And that looks too messy. So your very final answer is going to have 3I radical 2. Circle it. So the 3 made a date from the number 18. The radical 2 was left inside. The letter I comes from a negative being underneath the radical. Now, if you have a perfect square under the radical, you can still make some dates. So 25 can be broken down into that -1 and a positive 25. 25 can be broken down into 5 times 5. You can make a date with the 5s. Your -1 means the letter I. So for B, your answer is simply 5I. So with A and B, both of them simplified, and both of them had an I that you could take out. With letter C, I still want you to simplify it and break it into a -1 and the number 7. The -1 means there's going to be an I that you take on the outside. The 7 does not go outside the radical, so your final answer is I radical 7. Okay, with letter D, you can still break it down into that -1 and that radical 12. And 12 can be broken down into 4 and 3. 4 can be broken down into 2 times 2. Your 2 and your letter I, because you had a -1, can go on the outside. 3 is going to be left on the inside. So those are all of the different ways that you can simplify using I.